Before we discuss spirometry testing equipment, we need to review some environmental considerations for the testing area. The American Thoracic Society recommends that spirometry be performed at ambient temperatures between 17 and 40 degrees Celsius. That's between 63 and 104 degrees Fahrenheit. Testing performed outside of these ranges may cause inaccurate reporting of the worker's results. Spirometer performance standards are published by the American Thoracic Society and the European Respiratory Society, ATS-ERS, in their standardization of spirometry guidelines. These standards are important for reducing measurement variability and improving the accuracy of spirometry measurements. Spirometers should meet or exceed specifications outlined in this document. A free copy of the ATS-ERS guidelines is available for download on the American Thoracic Society website. The American College of Occupational and Environmental Medicine reiterated the ATS recommendations and recommended additional features for spirometers used in the occupational setting. Every spirometer model should be validated by independent testing prior to manufacturer distribution. This testing uses a waveform generator to produce 24 different simulated spirometry waveforms. You can obtain this certification from the spirometer manufacturer. Spirometry systems need to provide real-time graphical displays for use by the technician during the test. They need to display both volume time and flow volume graphs. Spirometry software needs to have computer-derived technical quality indicators, including a dedicated routine for verifying spirometer calibration. It is recommended that software store at least 8 maneuvers within one test session. Both volume time and flow volume graphic results need to be stored from at least the 3 best maneuvers. Preferably, the spirometer needs enough memory to save all the maneuvers from one testing session.
There are 2 basic types of spirometers, flow and volume. The flow spirometer measures the speed at which air moves past a sensor. The other type of spirometer directly measures the volume of air. This is called a volume spirometer. Flow measuring spirometers directly measure airspeed through an open circuit and calculate volume. Most are smaller and more portable than volume spirometers. Flow spirometers use 4 basic measurement technologies to measure airspeed. Pneumatachometers measure pressure on both sides of a resistance element. Turbines count the number of vane rotations within the breathing circuit. Ultrasonic spirometers measure the time it takes a sound pulse to cross the breathing tube. Hot wire anemometers measure the electrical current needed to maintain a superheated wire at a constant temperature. Flow spirometers must be able to accurately measure a wide range of airflows. Volume spirometers use an earlier and simpler technology. Volume spirometers directly measure the amount of air exhaled and collect that air in a chamber. With the appropriate software, volume spirometers can display both volume time and flow volume graphics as recommended by the ATS-ERS guidelines. It is standard practice that a 3-liter volume calibration syringe be available for every spirometry system, whether flow type or volume type. The accuracy of the calibration syringe is a critical factor in the process of ensuring that spirometry results are valid. The syringe needs to be stored near the spirometer, out of direct sunlight, and away from heat or air conditioning sources. The syringe manufacturer can recommend how often to return the syringe for recalibration. If there is no recommendation from the manufacturer, then the calibration syringe can be recalibrated every 1 to 3 years. If the adjustable ring stops along the plunger are loose or have been moved, or if the syringe is visibly damaged, it must be considered out of service until it is recalibrated by the manufacturer. Air in the lungs is at a different temperature than the exhaled air measured by a spirometer. This can affect measured expiratory volumes. Therefore, it is necessary to correct for these temperature differences. Depending on the type of spirometer, manufacturers may preset their conversion and tell the consumer that it is not necessary to correct for ambient conditions. Regardless, NIOSH strongly recommends that ambient temperature and pressure be entered and reported during spirometry testing. At high altitudes or during research studies, consider using ambient pressure conversion factors. When conditions change, be sure to re-enter the new values into the spirometer. A high-quality thermometer and barometer are important tools that enable a technician to monitor the testing area for changes in ambient conditions that can affect spirometry results. Clinic personnel must be able to accurately measure a worker's height and weight prior to spirometry testing. It is particularly important to measure standing height rather than using self-reported height. A stadiometer or wall chart may be used for measuring height. Measure workers' height without shoes. Periodically, calibrate the weight scale as outlined by the manufacturer. The technician ensures that enough disposable supplies are available in the testing area. These supplies may include mouthpieces, bacterial filters, and nose clips. The spirometer manufacturer may have a specific type of mouthpiece or bacterial filter that fits the spirometer. Place a chair with no wheels behind the worker. Have a trash receptacle available for discarded mouthpieces, nose clips, and other materials. Follow your institution's requirements for disposal of medical waste.
In our next module, you will learn how spirometry equipment is calibrated and how to troubleshoot when equipment fails a calibration check.